All right, in this video, we're going to go ahead and take a short break from calculating and look at probability notation, probability rules, and an extra tool in our toolbox, which is complements. First, let's take a look at the probability notation that we saw in our last video. So we use the probability notation to describe the probability of flipping one head and one tail when flipping two coins, or one coin twice. And we discovered that that was 0.5, or 1/2, or 2 out of 4. We're always going to use this notation when we are describing probability, and you should always write your answer in this way. So first, capital P, we could guess that stands for probability. If I could spell, which I can't. Specifically, probability of. And then the of part comes in the parentheses. Probability of. And then this is a description of the event of interest. So one head and one tail, or rolling a 6, or drawing a queen, or having rain on Tuesday. This is generally a description in words. Sometimes it'll include numbers, but those numbers are a descriptor of the event and not the input to a function. And that's sometimes a little confusing, particularly for those of you coming like right out of high school in Math 3, where you spent all school year talking about things that looked like f of x equals, and then you had a function over here, and you learned that if you put a number into the parentheses, that number replaced the variable on the other side. This is not what we are doing with statistics notation. So this notation here is not function notation. This right here is called probability notation, and it is a very different thing. We read this as probability of, and then the thing we are finding the probability of. The only actual calculated numbers we should see are on the right side, where we write the actual value of the probability. So we had 2 out of 4, which equals 1/2, which equals 0.5. That's where that came from. It came from that probability fraction. I should never, ever, ever, ever write this over here. And that is the mistake that I see an awful lot as students first start to learn about probability. So that's something to look out for. Anytime you are writing an answer to a probability question, you need to include this probability notation as your header, and then equals, and then your answer. I would encourage you to write out all of this as this first fraction is usually where the mistake happens. So if you have questions about your homework as you're working on probability, having this fraction to refer to is going to make it more clear where the mistake happened, and it's going to be easier for us to track it down. All right, the next thing I want to talk about is how to check our answers, and that has to do with some rules that probability follows. So the first thing you need to know about probability is all p of x's are between 0 and 1. Inclusive, meaning they can be 0, they can be 1. They cannot be smaller than 0, so no negative numbers. They cannot be bigger than 1. This one's super important when we move forward in later weeks and we talk about hypothesis testing. You're going to be calculating something called a p-value, which is a probability. It should never be bigger than 1. And sometimes your calculator is going to give you something that looks like it's bigger than 1 and it's not. And we'll see more of that in later weeks. The other thing we keep in mind is that the sum of all of the probabilities for the entire sample space, so all outcomes, should be equal to exactly 1. And that has to do with what that 0 and 1 mean. If a probability of an event is exactly 0, it means the event never happens. It's not possible. For example, drawing a yellow card out of a deck of red and black playing cards. Can't, because it's not there. 1 means the event will always happen. So for this rule, I'm looking at all possible outcomes. Everything that's possible is in that set, which means I have covered every event that can possibly happen. So every result I get is going to fall in this category, so its probability should be 1. Everything that's going to happen falls in that list, so that should always occur. All right, the last rule that's going to be helpful is this idea of complements. So I can't spell tonight. The complement of an event is equal to all outcomes that are not A. Typically, we write this as A and then a little C for complement. Sometimes you'll see it written as A prime. I prefer the first one. It makes it more obvious. I don't remember which one your book uses. The nice thing about this is that event A and all of the outcomes that are not A should be all of the outcomes in our sample space. So PA plus P not A should add up to 1. What that means is PA is equal to 1 minus the probability of the complement of A, and that the probability of the complement is equal to 1 minus the probability of A. Sometimes, when we're working with a probability distribution, one of these will be easier to calculate than the other, and that's where this complement trick is going to come in. So we will see that in an upcoming video. If you have any questions on what you just saw, feel free to send me an email or drop by my office hours on Tuesday, Thursday. Otherwise, I will see you in our next video.